Hi guys, today we're going to look at displacement reactions for group 7 elements. So we're going to start off with the starter as always. So which element is the most reactive halogen? So halogens is another name for group 7, and if you remember, the most reactive is found at the top of the group. So fluorine is at the top of that group, so fluorine is the most reactive. You'll need to know about this list, the reactivity of group 7 today, as we go through this PowerPoint, because we'll need to know them in order to do displacement reactions. So where do you find metals on the periodic table? All metals are found on the left of the periodic table. That's a very generalized answer. They're actually to the left of the stepped line. But if you just imagine them being on the left of the periodic table, that will serve you pretty well. And then the final one, what is the chemical symbol for chlorine? Well, chlorine has a chemical symbol of big C, little l, so Cl. Right, so there's nothing to work off. I'm just going to talk you through what a displacement reaction is, give you some examples to have a go at yourself, and then hopefully you should be able to do this no troubles. So displacement, this word here, is just a fancy word for switching, basically. So it's a reaction where two things switch, and they switch based on their reactivity. And I told you before that you'd need to know the reactivity of group 7 elements. So let's have a look at that first, and then I'll tell you the definition of a displacement reaction. So here's group 7. Now at the top of that group is fluorine. That's the most reactive. Then it goes chlorine, bromine, iodine, and there's one at the bottom, but we don't need those for today. We're just going to stick with these here. And another key word for today is diatomic. And diatomic is where atoms exist in pairs. They don't like to be on their own. So fluorine, chlorine, bromine, iodine, and all the other group 7 elements are all diatomic. So we put a little 2 at the bottom of each one to show that, to indicate that. And that shows that fluorine exists as a pair. Two fluorines bonded together like this. So fluorine, chlorine, bromine, and iodine. So these are all simple molecules and they're all diatomic. They exist as pairs. So now we know that this is the most reactive element. Iodine at the very bottom here must be the least reactive. So I'm going to leave this on PowerPoint because you'll need to know this as we go through. Displacement means switching, as we've talked about, and it's where two things switch. It's where two halogens switch based on where they appear in their reactivity. And there's a bit of a rule that goes along with the displacement reaction, and I'm going to write it down here, and it's important that you know this as well. The displacement reaction is when the more reactive halogen switches or displaces the least reactive halogen in a compound. And we're going to have a look at some examples of these. There's also another thing that you need to note. When a halogen is in a compound, it ends in IDE, so it's chloride, fluoride, bromide. But when it's on its own, so when it's not bonded to anything, it doesn't. It ends in INE. So it's fluorine, chlorine, bromine, and iodine. So we'll write that down now. So just to recap, halogens in compounds end in IDE, so fluoride, and halogens not in compounds end in INE, so fluorine. So let's have a look at a displacement reaction. So like I said, we'll leave the reactivity of the group 7s here. So fluorine, chlorine, bromine, and iodine. And let's have a look at an example of a word equation. So here is potassium chloride. It's potassium chloride because it's in a compound, so the halogen, chlorine, ends in IDE, ide. And if I react potassium chloride with fluorine, what are the two products I get back? Well, first of all, we have to look at the halogens. We have to identify them in the reaction. So the halogens in this reaction is chlorine and fluorine. And then once you've identified the halogen, you need to see which one is the most reactive. So in this case, fluorine is the most reactive. So fluorine displaces or switches with the chlorine in potassium chloride. They switch because fluoride is more reactive, and we know from our rule that the most reactive halogen switches with the least reactive halogen. So what you need to do is write it out again, but this time you need to put these in the different places. So we have potassium, fluoride, because fluoride has switched here, and it ends in IDE now. It's no longer fluorine because it's not on its own, it's in a compound, so it goes fluoride. Chloride that was in a compound now becomes chlorine because they switched. Let's have a look at another example. So here you have potassium bromide reacting with iodine. Now identify the halogens. So you have bromide, which is a halogen, and iodine, which is a halogen. Then you need to identify which one is the most reactive, and you look at this list here. Well, bromide or bromine on this list here is more reactive. So iodine, the one below it, isn't reactive enough to switch. It can't kick out the bromine from potassium bromide. It's not reactive enough. So because there is no reaction, you just write it out again the same. Just like that. Now there is one thing to point out. When writing word equations, you must make sure there are no capital letters. It's generally a good idea to write them all lowercase. Now we're going to have a look at doing some of these, but with symbols instead of words. So let's have a look. The easiest thing to do is to convert a word equation into a symbol equation. That way you can see where the symbols have come from. So you'll need a periodic table for this. And the first thing to do is start with this one over here. The symbol for potassium is K, capital K. And if we use our symbols here from the halogens, you see that bromide is here, it's Br. Now you might be tempted to write Br2, but that would be wrong. The reason that's wrong is basically due to charges and the way that these compounds are constructed. I've done a video on that once before. So you'll need to go back and have a look at constructing chemical formula if you don't understand. I'll show you an easier method though for doing this, and then you will know where to put the little 2's. So the first thing to do, look for the symbol on the periodic table and just write it in. So potassium is K, bromine is capital B, little r, plus chlorine is capital C, little l, arrow. Potassium, we've already done, is K. Chloride, well, that's the same for chlorine. It's just when it's in a compound. So capital C, little l, plus bromine. Now here's the trick. If I want to know where to put little 2's, all I do is look for every halogen that's on its own, and I add a little 2. So let's start at the beginning. KBr, is the halogen on its own? No, it's not. It's next to this other metal here, this potassium, so I don't need to write a little 2. Is the halogen on its own here? Yes, there's nothing else around it, so I'm going to add a little 2. Next thing, is this halogen on its own? No. Is this one? Yes, so I add a little 2. So even if you don't know how to basically construct these symbol formulas, you can just do that way and it will work every time. Now the one thing that you might have noticed is that this equation isn't balanced. If you have a look, we've got 2 bromines on the right, but only 1 on the left. We're going to have a look at that later on in this PowerPoint to see how to balance these equations. But for now, I just want you to be able to construct symbol equations for these reactions. So we're going to skip it at this stage. I'm going to write one more and I'd like you to have a go at this one. So pause the video, then unpause for the answer. Right, so let's go through the answer. Sodium on the periodic table is Na. Bromide is the same as bromine on the periodic table, so it's NaBr, like that. Fluorine, is F. Sodium, still Na, and fluoride is the same as fluorine on the periodic table, so F, plus bromine here, which is Br. Now, hopefully you remembered, every halogen that's on its own in the reaction needs a little 2 at the bottom. So that means that this needs a little 2, and so does this. And there you have a symbol equation. Let's have a go at balancing these symbol equations now. I'm going to change the colour of the pen so we can see what's going on. The first thing to do, if you remember the balancing equations video, is separate each side of the reaction. We need to separate the things on the left, the reactants, from the things on the right, the products. And then what we do is we're going to start by balancing whatever is unbalanced. And in this case, I just want to pick one. And we're going to start by balancing this here, the Cl2 on the left. We have 2 Cls on the left, but we only have 1 here on the right, and I need 2 of them. So what I need to do is put a large 2 at the front of the whole compound. The reason we have to do that is because the rules of balancing equations state that we can only add large numbers to the front of compounds and elements. Again, there's a video on this if you don't quite understand what's happening. So now here we have 2 chlorines, but it's also multiplied our potassiums by 2. That's a problem because we've only got 1 on the right. So we have 2 chlorines and 2 potassiums. So we need to multiply the potassium on the on the left by 2 as well. So now we have 2 potassiums, but we also have 2 bromines. Well, that's perfect. We don't need to do anything to the bromines on the right because look, there's 2 of them already. That little 2 multiplies things to the left, so we have 2 Brs. I'd like you to have a go at balancing the one on the bottom. So pause the video and then unpause for the answers. Right guys, remember the first thing to do, separate either side so you don't get confused. Balance the halogen on the left first. So we have 2 fluorines here, but only 1 on the right here. So we need to add a big 2. That gives us 2 fluorines. But it's also given us 2 sodiums as well. So we need to go back now and balance our sodiums here. So I'll put a 2 there. That gives us 2 sodiums. But it's also doubled our amount of bromines here. but that's fine because it's balanced on this side here. We don't need to do anything. So that is balanced, just a 2 at the start of this sodium bromide and 2 at the start of this sodium fluoride. Okay, I'm going to leave you now with 4 questions to have a go at. If you need any support or answers to these questions, put a comment in the box below and I'll get back to you. Okie dokie, bye.